come on the Saturday. I think I also have carried something, I don't know whether I even put it on time. Some stickers actually. Anyway, I'll find it. Okay, so my name is Wriju and I work for Microsoft. And what I thought today, I will share something around this. So this is fairly a simple and basic stuff, but it is important because a lot of application nowadays goes in this direction. So I thought of sharing what Microsoft really offers in the cloud, because eventually the container means cloud. So it's not always the truth, but I thought maybe I'll give you some idea. So this is the high level, let's say, architecture diagram we can call it, where we will be actually creating an application, containerize it, that's all I do in front of you, and then I put it in the container registry. So it can be any registry, and then eventually we'll try to deploy in one of them, and I've got the script and everything ready for you so that you can try. So I will show you where you can download the script and try by yourself. What I will also use today is purely a browser-based way of developing. Okay, so I will not use anything which is on my machine. That means a Visual Studio Code. So what I'll use is something which is very interesting, and I love that way because then I don't need a dependency on, especially in this kind of demo where machine don't work properly. Sometimes you can switch to your colleague's machine and then still can show the demo if you have the username and password of those services which you are using. So I'm going to show you that. But just to have you an idea, right? So you see that this is an Azure container instance. So when you have a single container application, and then it's a fairly simple application you need to run, you don't need to, let's say, spin up a whole cluster of containers, orchestration, etc. So you may need a simple container. So what people generally do, they create a virtual machine, install the Docker runtime, deploy the container, expose the port, and then do all those things. You don't need to do that. So we have a service available which essentially does that, and what you need to just provide the image from a registry to that service, and they will host your container, single container. But that's typically not the case for most of the production applications, so you will not go very deep into that, but there is an option if you want to run. App services is a web-based application, generally HTTP endpoint, so you can either have an API or a website and host it as a container. So you can build a container-based application and host it. Essentially, you don't need to manage the Kubernetes, because the moment you go into Kubernetes, you need to do a lot more additional stuff to understand the Kubernetes way of deploying container. You may not need that complexity, right? Because maybe your application is a fairly simple one, you just need a business logic running somewhere as an API, okay? So just you have three options. So whichever suits you the best, you choose that. I know the time is short, I need multiple hours to explain you it slowly. What I will do, I will go very fast at the beginning, and then I will go back and then try to show you how I build that application. Because building that application sometimes takes time, and if I start with building that application, I might lose the important part of that thing. So I went by the suggestion given to me that you go the important part first and then show the less important part later. So what I will show you is I have already created a container and put it in a registry. So the registry is something where you basically download the container images from and then deploy it anywhere. So it's like your single source of truth, and then the moment you have new version, you put it in the registry. So you can use Docker Hub. So Docker Hub is free. So all the things which I'm trying to explain to you are mostly free. So you can also try without paying anything or sharing your credit card information. So you can just go and sign up in the docker.io. It gives you an ability to deploy container, okay? So keep the container in the registry. So I have them open in my screen, so let me open that. So this is what it looks like. So let me increase the font size. So you can see that I have just a login here. It's a free login. I didn't pay anything. And you can just create, let's say, images like this. So you basically create a repository and upload the image over. So I have done that already. So all of them are working conditions. So I can either pick Nginx, which is a standard image from Docker. I didn't build anything. But the Web 2, Web 1, Simple Web are the application which I built by myself. So you can pick up any one and then deploy a container. So how do I do that? Now I need a place to deploy a container. So I can either use Azure Container Instance, that is a single container. I can use an app services, which is a web-based container deployment, or I can use Kubernetes. So let's use Kubernetes. And then I'll explain you later. And I'll show you step by step in the Kubernetes one, right? So what I'm going to do is that I'm going to use something called a cloud shell. So I can use the same thing in the local machine. Everything is configured in my local machine. It's a developer laptop, so I have got everything configured. But I don't want to show you because you need to go through a process of configuring a laptop, right? So this is on my Azure subscription. I can open something called shell.azure.com, and it opens this box. And here I can run either PowerShell or Bash script. So you have both options. We call it Cloud Shell. So it runs completely on browser. So if you are not a local admin to your box, in some cases in enterprises you get machine where you do not have rights to install, you can go ahead and use this and play around with Azure, right? So this is what it is. Now if you are logged in, you will always be logged in, because to log into this you need to log in to Azure first. So we are already logged in. So the step number 1 is already configured. If you're using a desktop-based Azure CLI, then you first log into that. So you use something called AZ login. It will prompt you and then you log in and get connected. So it's just same token thing which you have heard before happens, right? Now let me increase the font size so you can see that from the back it's visible, right? So if I say AZ account show, just to verify which account I'm connected to, so you can see that I'm connected to one of the subscriptions, which is MSGNWG 2021. Okay, so I'll show you what is there in that subscription. So this is my Azure. I log into portal.azure.com. It goes into there. You basically create all the things which you need to deploy. So I have a script to do that. I will share the script with you. It's all public, so you don't have to spend time and wait probably 15-20 minutes to create all those resources. Kubernetes sometimes takes a longer time, so I created that all. So you can see that I have got Kubernetes service. I just jumped directly into that Kubernetes service, and I will be able to see a Kubernetes service in the same subscription, that is MSDNWG 2021. I just wanted to make sure that I'm in the same subscription. Okay, so I'm here. Now when you have the Kubernetes cluster created, okay, it's just a one single line Azure CLI to create a Kubernetes cluster. So it doesn't require you to do a lot of stuff. You don't need to know what is happening behind the scene. You don't need to be an admin to create a Kubernetes cluster in Azure. Okay, that's the beauty of it. Now you can see that it gives you an ability to connect. So you have an option on the top called connect. What it does, it shows you a simple script how do you connect to the Kubernetes cluster. Now if I can zoom it, here you notice that it gives you some Azure CLI command. First one helps you connect to the right subscription. So it is important because if you have multiple subscription access, you sometimes log into another subscription and you try to do something which doesn't work. So it makes sure that you are connected. So I've already tested, so I do not need to run this. But what I will do that, I will run the second command. What the second command does, it gets me the certificate into my local box, whichever box I'm working from. So in this case, it is Cloud Shell. So it will get the certificate. So Kubernetes does not have any user concept. Okay, it doesn't have any user concept. All it does is certificate. Okay, so it is certificate which gets downloaded into my local machine, and that's how I can connect to the Kubernetes cluster. Okay, so this is the second command. If I copy this command, which this Azure thing does allow me to do, so I can go to the connect and copy, and I go to this Cloud Shell. Maybe I can run it individually, and I paste it. So what happens is that the certificate will get downloaded. So I've done it before, so probably it will say current context is this. So I'm now in my local, imagine this is my local desktop. So in other case, I'll probably be running in local machine. So it is now connected. Now Kubernetes has got a CLI capability. That's a command line interface, and that's known as kubectl. Some people call it kubectl, kubectl. So it's a command line utility through which you can work against Kubernetes. Okay. So I will use that. And the Cloud Shell, one of the good things about Cloud Shell is that you get all the tools configured and installed for you. You don't have to install kubectl. It's there. So neither you can install. So you don't have rights to install. So if I say kubectl, I get the kubectl options available. That means it is installed and configured. Now what I'm going to also use is an alias, which helps me do things a bit quick. Now by doing that, I essentially replace the whole kubectl into K. So every time I don't need to, kubectl CLI starts with kubectl word. So every time I don't have to parse this kubectl, I just pass. This is a Linux feature, so nothing special about Azure. But I just go ahead and get this kubectl kind of ready. Now what I'm going to do is that I'm going to test one of the images in my Docker Hub, see if I can download and create something in Kubernetes. So let's try that. So let's go to the Docker Hub, and if I, let's say, assume that I will use this Web 2 maybe, and I might have multiple versions depending on how many times I have uploaded it, right? So you see that you have this Docker push option, all this command, and you have multiple versions. So let's pick up the latest one. This is V1 2.1. Okay, so that's the one which I have here, and you can see that I have image name like this. So I copy the name of the image. Okay, that's the whole URL of the image. Now in Kubernetes, if you don't mention the whole URL, it assumes that you are connecting to Docker Hub. Okay, that's the default configuration. If you have to connect it to some private registry, you have to give the full URL. That's the only difference. But I am not connecting to any private registry, so you are using the Docker Hub, so it's fine. So I go back to this and I create the first Kubernetes command. Now before you start, you just need to see if you are able to connect to the cluster before you can create a pod. So I'll say k get nodes. So if I do that, it shows me all the nodes which is basically running, ready. That means it's connecting to the Kubernetes cluster. The second thing is that I'm going to create the pod. Now Kubernetes doesn't allow you to run container on its own. So you have to actually create a pod which will internally run a container. So they kind of abstracted the container runtime from you. So you don't need to know which container runtime Kubernetes is supporting. You just need to know how Kubernetes runs a container, and Kubernetes will handle internally using container runtime interface, CRI, and that's why it can support multiple different kind of container runtime behind the scenes. So today, by default, it is something. Tomorrow it could be different. You don't need to learn Docker and other container runtimes to be able to work on Kubernetes. That's the beauty of Kubernetes, right? So I say k run, and I say web2 image, and I pass the image name. This is essentially going to create a pod. Now you can see that it's created. Just to check if the pod is created already. So I use the PO as a short form. You can see that it is running. So the web2 is running. That means it is fine. But I cannot test it because I don't have the IP address to reach out to this container. So how do I test whether this is running? So what I can do, I can create a deployment, and then I can expose that deployment to the public IP address, and then you'll be able to even access from your mobile the same application. So that's what I'm going to do. So I create something on top of the pod. So the pod is one box. I create another box which will say that this is my deployment, and in the deployment you can do many more different things. Deployment is a self-healing concept of Kubernetes, which means that you do not have to monitor pod. So if I go ahead and forcefully delete this pod web2, it will delete the pod and it will not recreate. Kubernetes don't care about recreating the pod until you put it behind the deployment box. So deployment box will ensure that number of pods you mentioned in the beginning remains the same. If one pod goes down, another pod comes up, and then if you have, let's say, multiple copies of the same pod, it will have load balancer and everything created. So it's easy for a large scale application. So when you deploy an API, do not deploy pod. You never deploy pod in production. You pod deployment, okay? So let's, yeah.
Is deployment a logical boundary or physical boundary?
It's a logical boundary, yeah. So if I say k create, that's kubectl create. Every time I type k, it's kubectl. Create deploy. You can type full deployment or you can say just deploy. And then I say image. And then I pass on the image name. That is what I copied. Okay? Web 3. I have to give a name. So you can see that the deployment is created. Now, what it essentially does, it creates two objects in the Kubernetes cluster. One is deployment object, another is pod object, and I'll show you that. You will notice the first kget pod. If I run the same command, you'll see third pod coming up with some random name. That is web3 dash some dynamic value. That is basically deployment. Now, what I can do, I can say k delete pod web2, and it will be deleted. And once it is deleted, it will never come back. But if I go ahead and delete this one, you will see that, you notice the last 4 letters or 3 letters, JLH, and if I say k get pod, you'll find a new one that is web3 dash and 2k2. That's Kubernetes did that for me. The moment it says that there is no pod, it will start creating a new pod. So that's a self-healing activity, but the web2 is completely gone because it was an orphan pod, right? So it was pod without deployment. So think of it like a monitoring agent. Yeah.
Is it the deployment that ensures that the pod is always there?
Yes. Yeah. That's a check which is constantly there. So it's like sort of like an agent which keeps monitoring the health of the pod. Pod can go down due to many different reasons. It can go down because your physical server is down, the node is down, the network is down, or the Kubernetes pod itself is corrupted due to some reason. So it will ensure that it makes that deployment healthy all the time and you have the required. You can increase the number of instances, by the way. So I did not mention, so it created only one instance. But the moment I say that I need more than one, that is 2, 3, 4, it will have those many number of pods under the same deployment. So you will find web3 dash some 4 pods, if I say 4. So you can even increase the capacity while it is running. So today, let's say you have a very limited user base. Tomorrow it increases, you just increase. So you can actually have a rollout deployment, which means it will increase the capacity up to certain level. So let's say 1 to 4. And then if you deploy newer version of your container, it will not delete all of them, it will roll out eventually. So it's a rollout strategy, which is the default one. So it will never go down, but it will replace with a newer version eventually for all the pods, right? So that's what happens. Now, this will not give me an access to the container yet. So I have got an application running, right? I need to access it. So I need something called a service. So service is something like a load balancer kind of thing you can imagine for us to really reach out to that. Now there are many different ways by which you can reach out to service, either by using cluster IP, node port, or in the cloud context, which I am using, that is Azure, there is something called load balancer, the cloud load balancer. So if I use the cloud load balancer, I'll get a public IP. The benefit is that I can use it from outside of the cluster. So I don't need to be part of the same network, same cluster. Public IP allow me to access even from my mobile. So let's see how we can do that. Fairly easy. So it's just a concept you need to make sure in Kubernetes it is clear what you are trying to do. Syntax remains the same even if it is a super critical application or a very simple application, right? So that thing where you need to put what. So if I now need to create a service, let's make it a big one because it requires a little bit of code. So if I say SVC, now I first say get SVC to see if I have any service. I have one service which is running, which I tested today morning, so it is fine, it's still running. So I'll say create. Now I don't need to give a name. Now to create a service, you don't say create a service. You basically go ahead and say k expose deploy, and it was web3 if I remember the deployment name. And then in this you have to say what port you want to expose this service to. So it's a web application, I'll say port 80, but I don't remember what was there in the web3. So let me go back into this and see if I have access to this. So you can see that there is something called 5106. That's the port internally the ASP.NET Core is using. So by mapping what is my target port will be, if I reach out just HTTP and the URL, that will be port 5106. So I have to mention that, otherwise the port mapping will not happen, because my ASP.NET is not using port 80. Okay, that's the only reason. If the ASP.NET is using port 80, then I don't have to mention explicitly the target port. Now here in the command, I have to also say target dash port. Sometimes this syntax may change depending on which version of the Azure CLI, Kubernetes CLI you are using. So it can be target port together with P capital, camel case. But here let's say I have 5106. That was the port number if I remember correctly. And then this is the most important part, last one, is the type. So what type of thing? If you don't say mention type, dash type, it creates a cluster IP. That's the default service type it's going to create. But here I say load balancer. If I say so and run it, it's going to go ahead and create a service by the name called web3. Okay, the name of the deployment will be the name of the service. If you need to change the name of the service, you can say dash name and give a name as your choice. So you can say web3 dash service, something like that. But you need to make sure that they are not having any special character, etc., because it will eventually create a DNS. So that's what it is going to do. Now, if I now say k get svc, you'll find a third service with a public IP address. So let me just reduce the size of this font so that they are not wrapped. So you can see that web3 service is having some public IP address. That is 20.239.3.28. If you type it in the mobile, you will find a website running in the mobile. And let me show you that. So if I just copy this, and if the port mapping and everything is correct, so it should actually show me HTTP. Some HTML. Okay. So it's working. So let's run it in the browser. Maybe I put it in the browser and it shows the version welcome v2.1. Okay. So this is typically the experience you have when you have a container image. And that's typically a DevOps activity, right? You have the developer create a container image given to you, and then you deploy it using the image. You don't make any changes. You just make changes where you want to deploy.
In the previous command, kubectl expose deploy.
Yeah.
Does that mean that deployment is actually referring to a web service?
Yeah, so it's a kubectl CLI way of creating a service. Okay, so it's so at the end of the day, when you basically build a DevOps pipeline, you don't use a CLI, you use YAML file.
Correct.
So if I run the same command and then say dash o YAML, that is output YAML, you will get the output of the YAML version, which you can copy and paste it in a YAML file and use it in the DevOps pipeline, right? So we don't have that CLI option where we can say kubectl create service. That is not there. So they use expose to create a service. Okay, so it's just a bit weird, but eventually you will not use CLI for anything, right? Because the CLI is only for testing purpose. The main thing will be all YAML. So every object which I have created, you need to create it in YAML, and you don't have to write YAML from the scratch. kubectl gives you an ability to generate the YAML. Okay, so that's also an option available for you.
You created that load balancer, right?
Yeah.
So that load balancer is a Azure resource or it's a...
Yeah, that's a very good question. So, thank you for asking. I forgot to tell about this. So, this is definitely an Azure load balancer. So, what difference we have in the Kubernetes on-premises versus Kubernetes in Azure or GKS or Google or AWS is that the public cloud provider does give or use something called a cloud controller manager. Okay, it's an additional component on top of the existing Kubernetes source code, which each of these cloud vendor uses. And what they do, essentially, by using the kubectl command line, they also create resources outside of the Kubernetes cluster. Okay, that's what this controller component does. Okay, so what this component is doing now for Azure, it is creating Azure load balancer. And Azure load balancer with the public IP address. So, and then attaching it with the service, which is Kubernetes object itself, and mapping it. So you have layers. So how that layer would look like, I'll just draw a simple diagram, maybe that will help you understand, is something like this. So imagine that you have a deployment, like this box, and you have pods. Under one deployment, you have multiple, so we have only one. This is deployment, this is pod, okay? And then you have something called a service, which is an object across the cluster of Kubernetes. So if you have, let's say, nodes in the Kubernetes cluster, so these are boxes, either virtual or physical boxes. So these are nodes, okay? So you have 3 node cluster, node 1, node 2, node 3, okay? And then in one of the nodes, you have the deployment and the pods available. If the pod could be available here also, no matter where you put. So it doesn't matter, it just keeps connecting. But this is the service. Okay? And then with Azure, it gets created outside of the Kubernetes box. Okay? Additional load balancer in Azure. So what this does, it basically gives you the IP address capability. Because in Kubernetes cluster, you don't get the public IP address concept, right? You cannot create that. So we, in the on-premises kind of concept, people used to use something called ingress controller. Right? So that's something which gives you an ability to create a load balancer with a public IP address, routing, etc. We can also use in Azure context using Azure component, but in the typical Kubernetes world without cloud, you use ingress controller to basically expose this internal service as an external service, and then you can map DNS IP address within this controller. So that's the different level of discussion, but eventually to reach out to this pod outside of the Kubernetes cluster, you can reach out to this pod from inside of the Kubernetes cluster, because each pod in Kubernetes gets an IP address, okay, an internal IP address, but that's only reachable if you're within the cluster, right? So if you're in one pod, you can reach out to another pod using that IP address. But that IP address can change, because the moment the auto heal kicks in, right, I delete a pod or the pod is unhealthy, the Kubernetes deployment will create another pod with another IP address. So if you have a fixed IP address to reach out to a pod, you might fail. So we always use service to reach out to a pod, and service has got an option to map the pod IP address on a constant manner. So it keeps monitoring the health of the Kubernetes pod, which are the pods, and it uses a concept of levels. So each pod will have level, and by that the service will map to the level and observe the health and see what is, there is a new IP, so it will immediately change this backend and make sure that your endpoint refreshes with the new IP. So I'll show you that how it looks like from this thing, Kubernetes concept.
Question.
Yeah, go ahead please.
So, how the communication happens in the pod that is residing on different nodes? You mentioned about 3 nodes, right?
Every pod has IP address. So I'll show you that.
What is the use of node in that case? I'm just trying to figure out. What is it?
So node is actual box. So imagine Kubernetes is a multi-node cluster, which means that multiple either physical or virtual boxes, operating system. It is Linux or Windows for the nodes. So you have multiple operating system boxes. They are connected like a cluster. And then you install the Kubernetes runtime on each of these boxes, connect them to a central something called a control plane. Okay, and that control plane can be multiple boxes or single box, depending on how big your Kubernetes deployment is, and they are all connected. Okay, so when you say that I want to create 5 pod, they might land into one single box or in all the boxes distributed. You can also enforce how that pod deployment may happen, because sometimes it is important, because in the data science world they use a GPU based machine. If you have only one node with a GPU support, you can tell pod that I want you to get deployed only in that node. So you can say taints and tolerations and all this to play, which means that in the Kubernetes definition file, which is written in YAML, you say that the pod should be deployed into a node with a taint and toleration with this. So you basically level it.
Is it kind of a logical grouping of nodes, kind of?
Nodes are physical.
Yeah.
Nodes are physical. The resources are deployed physically within the node, but you can give an instruction if you want to, let's say you want to deploy a special pod. In this case, if it is a GPU heavy workload, so you need a GPU machine. May not be all the node can have GPU, only one node may have GPU. And especially in the context of, let's say, Windows container. You can also run Windows container in Kubernetes. So if you have a node with Windows operating system, then only you can run Windows container. You cannot run Windows container on Linux operating system. So if you have a Windows container machine, so your Windows container should deploy it in the Windows machine. So that instruction you need to give in the YAML file, right? So that's something you can always give instruction. Yeah.
Some of the you want to install one application in 2 different OS. Using Kubernetes.
Yeah.
You can go ahead with that.
2 different ways of what? Like what are the openings? You don't talk about the operating system here. You talk about the container image of. So your
2 different images I know.
yeah. So there will be 2 different containers, right? One container cannot have 2 different images, right? So just imagine that you are running Ubuntu and Red Hat. Let's put it that way. There will be 2 containers. And in Kubernetes, you can host more than one container in a single pod. Okay, that's possible. So what I did is the default one, that is one pod, one container, but you can have multiple containers. And that's the concept of Kubernetes sidecar. So you have an application running in a container, and you have a logger running in another container. Logger may be a SUSE Linux, you never know, but your application may be using a Red Hat box, right? So your Red Hat application is logging things in SUSE, and you can create one pod for that because they go as a set together, right?
Your deployment decides how many pods will be created.
You decide, you tell deployment how many pod needs to be
But
created.
if I want deployment to decide, like it should be dynamic, I don't want to give a particular number 3 or 4.
So then auto scaling comes in.
Wait, happy is it?
Yeah, so then you have to enable the auto scaling.
And it will remove also, no? When
Yes.
happy-
Yeah. So you will remove and this thing.
The Docker port which we are using, that is web app port, or what exactly that? The port you copied and then you started running the application.
It's a TCP port. It's a simple TCP port in that
And
container.
that's the IIS related port, or is that different? The port you copied and then the web app application you created. So if that port is the web app port, like I usually run the application and then we
That
have-
5106 you mean to say? Yeah, so the image I'm using is a ASP.NET Core website. And I'm going to build that in front of you now. So that is running on a Linux box. So there is no IIS. Okay? So it is running on
because it is in process.
Crystal.
It is in process, right?
It's in process. So that's why dynamic code, you see dynamic code.
If it is in process, then it's better to go for window deployment, right? Window container.
It's up to your choice. So you can have a ASP.NET Core application and deploy it in Windows on IIS and build a
If it
container.
is a big application, performance issue, something like that. Because it is in process. Because you have to go, if I'm using a Castle, then it is out of process actually.
So it is application developer or architect's choice to decide what port they want to use. So whichever port you use, at the end of the day, you can expose it as a public
Because if
website.
it is 5000, it's a Castle is running.
Yeah. So it's up to you. As I said, like it's totally depending on the application thing.
Because if it is out of process, costly it is.
I didn't want to bring in the quantum physics into this demo. That's why I created a very simple one. But that may not be the
I got it actually.
yeah. But I mean, like, it's your choice. So you can actually host it in complete IIS. That's not a problem.
Because when we send a request, obviously it is go to not Castle, because it will go to IS itself, because in core means we will go for Castle, but 5106 is a IS once again, so it is in process only.
I said, like, it's a developer and the architect's choice to decide how that container image will be built and what port they want to use. So I use the default what my thing does and just went ahead with it just to show that it works, right? But if you want to, let's say, consider performance, etc., right? So you can go up whatever the suggested way of doing it.
So is it still available for on-demand?
Yeah, visible.
Can we take a look at that whiteboard diagram once again?
Yeah.
So the hierarchy is you have inside pods, you have the actual ASP.NET Core application running.
Yeah, inside pod you have container.
Inside pod you have containers, and there can be multiple containers in a pod,
Yes.
and multiple pods inside. What is that thing called?
No, deployment.
Deployment.
Yeah. It's just a logical grouping, right? It uses something called label. So each pod will have a level. So maybe a web 3, web 3, web 3. And deployment will just monitor the level. So you bring in another pod with, let's say, same level. The deployment will start monitoring that one also. Okay? And then, if you, let's say, whatever the deployment minimum number is, so in this case it is 1, you can have 2, 3, 4 replicas, they call it, number of replicas. If it doesn't match with that number of replica, let's say less than that, it will immediately spin up another pod. Deployment will take care of it.
And there can be multiple of these deployments inside a node. Is that?
Yeah, this is Node, this is Box actually. This is the actual operating system. Linux operating system on top of which the Kubernetes runtime is running. And then all these things are managed by something outside or within the cluster as an outside component called Kubernetes control plane. It's like a manager sort of thing who observes and does schedule, checks the health, and if the one node goes down, then it takes care of that part. If you want to add additional node because the capacity is increasing, so all these things. But in a cloud concept, you don't have to really worry about this thing. You say that I need 3 node, 4 node, 300 node, Kubernetes will manage it for you, right? So it's just automated direction.
And in AKS, all these is this is like a PaaS service.
It is a hybrid, huh?
The creation of the node, I don't have to manage it. It auto.
No. You don't have to manage. So it uses the concept of like auto scale and all these things. So if you enable that, so in case of, let's say, the node capacity is maximum reached, then it will spin up additional node. But if you say that I want to fix only with 3, 5, 50, so it will be fixed in that, no matter, and then, so it is all managed for you. Yeah.
When we run the command kubectl expose to create that load balancer, so that command of expose is part of the Kubernetes or the our AKS module, which is the controller actually, which takes that command and creates the load balancer.
Only the last part of the command was part of AKS, which is type load balancer. -- type equal to load balancer works only when you have Kubernetes in cloud. That can work with Google, AWS, and Azure, because it uses a component called Cloud Controller Manager. When you talk about Kubernetes on premises or without cloud, then you don't have that, so it will fail in that part.
Correct. So how the things will get exposed then? Because
So I said I use something called an ingress controller.
So ingress I have to configure outside and use that ingress.
So ingress controller is an object in Kubernetes again,
Okay.
but it allows you to do the load balancing and traffic routing. So if you have, let's say, you have an e-commerce portal, so and in the e-commerce portal you sell books, watch, CD, DVD, and all these things. So you want to say /books, it will land into a set of pods. /watches, it will land into some other set, right? So you can redirect the traffic based on the URL. So how do you define that? You do it in the ingress controller level. It's again a pod-like concept and does that.
So in this diagram, if we consider controller plane as a big umbrella, under that nodes will come, under that pods, under that containers.
No, controller will be another set of nodes actually. It is not an umbrella.
Okay.
It is, let's say, an observer keeping track of what is happening in the node.
Master. Okay.
Yes, master. It's like a master.
Okay.
Yes.
Under the node, pods will come.
Yes.
Oh.
That's where it has to land because it's an operating system.
Okay.
It could be a Linux operating system like Ubuntu, Red Hat, or it could be a Windows operating system. Node. But controller has to be Linux, only Linux. Yeah.
Suppose a scenario is there that application is badly written or somehow keeps on failing. So pods keeps on getting recreated again and again.
No, it will not recreate because pod is still in a failed state.
Yeah.
So Kubernetes only create the pod if it is destroyed. Yeah. So if your pod is failing, if I create a bad, I'll show you how it looks like. So it's a good question. You should get a chocolate. I'll show you with a bad pod. So if I create a bad pod under deployment, let's see what happens. So I need to run them side by side. So what I'm going to do is that I run here and then I run something like shell.azure.com here. Okay, one will just monitor, another will show you. Okay, so if I just go ahead and say k get pod and -w, that basically will show me the what is happening in the pod world. So just observe that. And in this side, I'm going to create a pod with a deployment. Let's say I'll say create deploy web 4 with an image which doesn't really exist. My image. It doesn't have an existence. I don't know if people have created it. Let's report that my initials also. So I try to create a pod. Right? So you can see that container created, error in image pool. There's a problem because that image doesn't exist. And it will just stay there. That number will not change. That is 4kfkjh. Because for a deployment there is a pod. Inside the pod you have a problem. That is not a hierarchy of deployment. Right? But if you delete this, see, it is kind of constantly changing the status. First it couldn't pull the image because there is no image. And then image pull back off. Error in image pool, that remains same. This pod never changes. But if I let's say copy this pod and try to delete it.
Can you please run kget pod -w once again?
Yeah. So you'll find the same thing. I'm running that only here.
Okay.
So it's a watch mode.
Watch
Whenever there is a change, it will change. Okay, it's a live feed. You can imagine. Now, if you just go ahead and copy the name of the pod, okay, just this one, and delete it. Forcefully, I don't want to delete it. Delete pod, and then this pod will get deleted multiple times. Goes up to H. Here. Now you can see that the thing changed, right? Now there is a new pod. Okay. There is a new pod, ZLWNB, but it has the same problem. The previous one is terminated, it's getting deleted. While it's getting deleted, the deployment triggered because it understood that it is getting deleted. Now there is a problem in the deployment. Now deployment is active. Till the time there is an internal problem, deployment is not having any issue. But the moment I delete it, that is terminating, and eventually it will be deleted, you will not find that. It is having the same issue because I have an issue with the image. Now I can edit it on live also, so that's also option available. So I can say that I edit deploy web 4.
You mentioned something called probe, right?
So what I'm going to do, I know the issue. The issue is that with the image, there's a problem. So if you give the exam called Kubernetes CKAD or CK, you have to go through these exercises, right? So they will give you a problematic thing and then you have to fix it. So what I am going to do is that I am going to just use this image thing and replace this image. So it's a so now I say Nginx. Huh? That's a typical standard web image, and I just live change it. Now you can see that new container triggered because you made some changes in the container pod. Now you see that there's an old one will be deleted, a new one has kicked in, it's terminating, right? I didn't delete the pod, I just changed the deployment with the right image name, and it terminated, and you will see that it's running. Now the deployment is healthy with a one single pod running. You can even increase the capacity of the deployment. How do you do that? You just go and edit the deployment, right? And I just say that there is a replicas. So you just change the replicas to 4. You just edit, and you will see that there will be 3 new pods created in a running state. That's how deployment handles. You don't have to redeploy the pod. So the deployment decreases, you can actually get to see that reflecting. So you have 3 new pods with a running state because I now have a right image, right? And if you use some image which in the container world doesn't run for a long time, let's say a busy box or something like that, which is just a one, let's say, process, and as soon as the process finish, it ends, you'll find a different experience. So because it is web keeps on running, right? So web is always in running state, so you'll see running, but some basic Linux container if you use, and if it doesn't have any process running, and it runs once and then comes out, you'll find it as stopped state or maybe not working state, but it's not an error, by the way. So you just need to identify what is actual error, what is not. The initial one, which image pullback thing was real error because that image didn't exist. So Kubernetes couldn't find that image in the Docker Hub. So that's why the container the pod never really properly created, right? That's why the error. But now it's no problem, right? You can see that it's not changing anymore because everything is fine. But I can pick one of the pods and delete it. So I just pick one of them and I say k delete pod, and then that's why you should not create a pod. You should always create a deployment. Now it is terminating, and immediately there will be another one which will be coming up, which will be in running condition, right? Before it actually terminated, you can see a new one is started creating, right? That's how deployment makes sure that you have 4 replicas. In my case, it's 4 replicas. So 4 replicas will be always up and running. So it just immediately available. So your traffic, yeah.
The private IP address is assigned at the pod level.
Yes, at the pod level. So I'll show you in one of the pods. So if I just pick up any existing running pod which is now available, and if I just say k describe pod, you will find an IP address somewhere here. Yeah, so you can see that this IP address is the pod IP address.
Is it also using the Cloud Control Manager to provision Azure VNet?
Yeah. So if you are deploying it in AKS, you can choose to use Azure networking. Otherwise, Kubernetes does have its own networking solution as a plugin. Calico, Flannel. So these are all third-party networking solution. So if you manually deploy Kubernetes cluster on your own in a virtual machine, you have to install one of them manually.
When we created the cluster, we did not specify any address prefixes, we didn't carve out any subnet, so it uses default settings.
No. It's a pre-created cluster, so I created before this demo. So because it takes time, I didn't want to spend time on creating. But when I created the cluster, it actually first created, but the minimal script which I used actually created a virtual network first, and then a subnet, an IP range, and then associated that as its networking solution, so that now all the IP address is provided by Azure VNet. If you don't choose Azure VNet, you can have, let's say, Calico, Flannel. That also option is also available in AKS to provide you the private IP address.
And if I want to know, is it a Windows
So you can go to the node viewer and it will tell you the details about the node in the dashboard of here.
And what is the association between one subnet in a VNet to the pods? Is it like a multiple pods are assigned private IP addresses from one subnet, or is it across subnets? That part of
So I think it is a subnet. So you have a subnet IP range.
Correct.
So when you create a AKS cluster,
correct.
you have to say which subnet you are using, and that subnet provides you the IP range. So
Okay, like that cluster.
yeah, that is why if you have a smaller subnet with less than 255 IP address available in that subnet, you will get an error in the portal if you try to choose that subnet. And it will say you that you do not have enough IP address, right, to use it as its Kubernetes IP address provider.
Technically, I can have multiple clusters serve IP or get IP addresses from the same VNet.
Yeah, you can. Yeah. Provided you have that enough range available. Yeah.
And to run the Kubernetes in the locally, you can use even Docker desktop as it was.
Yeah, so you can use Minikube also. So Minikube is something which you can try for free. Just install it in your, if you have WSL, right? So you can just run Minikube in WSL, Windows Subsystem for Linux, and you will get the full experience of Kubernetes. You don't need to have Azure subscription or anything of that sort to create a cluster, because it is a paid thing, right? It's not free. You can also use something called Katacoda, katacoda.com. It's a OLE portal, right? It gives you a cluster through browser like this, and it's free. The only thing you cannot do is like what cloud load balancer which I am doing. It's not that remaining everything to cut off, and all the command you can practice it over there, try out without really installing the Kubernetes cluster on your own. Right? So that's something which you can. So I'll quickly go into. I'm not sure how long I have.
And this Azure shell, it will by
Oh.
default. Azure shell by default it.
Then I will show you the resources and then let you explore. So I'll not eat some of these things. Yeah.
Azure shell, like by default it will pick it, like if I want to create an image and then I want to add it into Azure Container Registry or somewhere. Like I don't want to use a Docker thing, and then we have a facility like how we can create it.
So local Docker, you mean?
No, I don't want to use a local Docker. I want to use a shell only.
Yeah, that's what I'm using, right?
So by default it will pick Linux or like any command you have to type it for.
So I'm using bash. So drop down says that. So you can see in the corner, here bash. So I'm using Azure CLI.
No, in Docker, like local Docker, I can shift like to Linux to window container and all that. So here how can we shift?
No, this is a dev container. From where you run command, it doesn't host anything for you. What it hosts is Azure. So what I'm doing is that I'm deploying my container to Azure's Kubernetes service from this. It's a command shell for me. Instead of local command shell, I have this command shell.
No, what I'm saying is, in local Docker, I can shift my window container also, Linux container also.
Yeah.
So is there any facility here, like I want to create a window container in shell itself? Like by
By
default,
container can be specified which OS it has to use, whether it has to use.
No, I said right. To run Windows container, you need a Windows image. That's must. If you have a Windows,
I want to create it.
so that's a development activity. So it's not a developer activity. You don't develop yet because you cannot install anything. It's just a toolbox given to you to reach out quickly. If you need to develop something, you need to have your own developer machine. Local machine, yes. And then develop. Let's say if you want to build a Windows container image, you need to build it on it. So I'm going to quickly show you a few things so that you can explore by yourself. I don't have much time, so I don't have any time actually. So I'll say GitHub, and then this is my first name and GH. If you go here, I probably will highlight this in a notepad. And then you can see that this is where I have everything. And if you go into this, you'll find a repository which will be in the top, probably called Tech Talks. And in that Tech Talk, I have all the things which I talked today. So under the scripts, you'll have 3 bash script, which will probably the last one is more interesting, which will create all the resources, right? You can pick up the script, and script is written in such a way it doesn't matter which subscription it is, and it uses random name, right? So I use the date to generate the resource, so you always have a unique name. So it will have a unique name. You can create that. You can change it to random variable. The only thing with the script is that if you use sh and the script name, the random $random doesn't work with sh. You need to use bash and the script name. So that I also mentioned in the command. I was getting that error. But only thing is that this script will create the resources. I also have additional script for you to create a virtual machine in Azure, which you can make a dev box, which I generally use. So I have Ubuntu VM, which I can connect from my local machine using VS Code. So VS Code does allow me to connect to a local machine, from local machine to a remote machine, and then work there. Because I use multiple different runtime for multiple different customers. So I cannot have that set up in my local laptop all the time. I have a primary setup, but that may not be suitable for all the customer needs, right? So I need multiple different configurations. So I always do that. So I have VM in Azure. I connect from local dev using something called remote SSH. That's an extension with the Visual Studio Code, and then you can reach out. And I have videos available. So if you just type in like how to use Ubuntu Dev VM, you'll probably reach out to my video. But there are multiple people who have written multiple blogs. They're beautiful blogs. And I have taken help from those blogs also. So you just do search, right? How can you create that? And you'll get that. This is important, and I want to quickly show you one thing, and then I'll end my talk. Is that what I was planning to show as a demo? Is that this one? Because I said that I will not use anything. So I was using something called a code space in the GitHub. So GitHub again is free, so you can go and create a login in GitHub, and then what you create is a repository. So once you create a repository, you get to see this button called code, and that is GitHub's code space. It allows you to create a developer environment on the fly for you in somewhere, and GitHub hosts that for you. And then you can do the full development in the browser. You don't need any installation. So you can actually go to a cyber cafe and do a full-fledged application development from there without having an installation. Right? That's something I recommend that you explore because it's free. Okay? And you can even configure things on your own.
So can you show the Copilot code?
Huh?
Recently announced Copilot. GitHub
Copilot, I don't have the demo ready. It requires multiple people.
Oh.
Yeah, so because I need somebody to actually work with me together. So it's a it's a joint development. Right? So,
Visual Studio also we have that, right? Code share,
yeah, so live share.
live share.
Where it will get host is I have to choose any cloud for this.
No, it will be hosted in the GitHub space. Here I don't have to choose anything. So it's a container image at the end of the day. It will spin up a container image for you, give you access for you, do the development. You don't need a Visual Studio Code, it's a browser-based Visual Studio Code. You don't even need that in your local machine. You can actually bring the code into local Visual Studio and then do the development locally. That option is available. But if you don't have it, you still can do it in the browser.
Can I use this? Can I do this coding in the online browsing with my legacy laptop, like 2 GB RAM?
Yeah. I mean, like it's on browser. You need a good internet connection. That's all. It's all about internet connection.
Is it in deployment version? Deployment version?
Latest, always latest.
So the thing you mentioned about code space is not free. You have to pay for it.
For you, for me, it is free. No, I am using a private account, by the way. It's not a Microsoft associated account.
Okay.
So I can access. That means you also can access.
Yeah, but you need to bill for it. I mean,
No, there is no credit card associated to this. It's a purely personal account.
it's not like that.
No association with Microsoft. I have another account, which is a corporate account,
Yeah.
where I have more access to many
That
resources.
must be the private preview or something.
Maybe I have signed up. I keep signing up all these preview things. So maybe I have signed up for that.
So even I'm in the private preview. While you're in the private preview, it's free. But once they come out of
Then I'll stop using it. Simple solution.
And one last question. You told that controller plane, right?
Yeah.
In the Kubernetes, it is only having the runtime of the Linux side. It is only Linux based.
It has to be Linux only. Only Linux.
No otherwise.
No. Control plane doesn't support any other operating system.
I think that was managed by the Azure.
That will be managed by Azure and hidden from you. You cannot access
You
that.
can't access.
You cannot even remote into that machine.
Also Azure doesn't charge you for that option.
No, it doesn't charge you for that.
Cost is a very important.
So you see that it's in browser. It's opening the Visual Studio Code in the browser because I clicked on the code space and it opened the workload. So you can see that everything which you see in local machines is visible just like that. So I have a terminal window, I can run Docker command, I can have the code, I can change the code. I can even run the code. I can say .NET run. It will do a port mapping and run. So that's all these things are available here. All right. Thank you.
You have to set up this .dev container file.
Huh?
You just have to set up the .dev container file to initialize your code space. I forget there is one file that you have to use to.
No, I think now they have a button. So you just have a button code.
Yeah.
You just initialize that, and it will open up.
Know which packages to install. I think there's a .dev container file.
Then it is up to you. It's just like a folder explorer.
Yeah.
So you can have a Node file, you can have .NET Core file, you can have Python file.
Yeah.
In the terminal, you need to run those things. You need to set up the task, build task. So you can just say Ctrl+Shift+P and say task. And if you have running one single runtime, you build the task.
Do the launch JSON.
So you can actually need to configure that task if you are targeting one type. So for example, it is .NET Core. I set a task for .NET Core. So every time I run a file here, it will build for .NET.
This is a little different from, you remember how Azure DevOps had its code space before it was deprecated and
Correct. Yeah.
So that one had a dev container file. It's similar to a dot file. And
Yeah.
that was used to initialize. This has it slightly different. I have not played around too much with it. But
Now this is very helpful when your laptop is broken.
For your diagram, I think there is one logical construct, namespace, right? You consider a pod, you talk about the pod, logic, then services, and next one is namespace. Right?
Namespace is a grouping of your resources. So let's say you have a production workload, testing workload, developer workload, right? So you create a namespace for developer resources. So you deploy everything in the namespace, you delete the namespace, everything is gone. It's like Azure resource grouping. So you're grouping the resources as a name. So it doesn't require, so I didn't explicitly mention anything namespace. No, it's not logical. It is just a grouping.
That's a tagging. Tagging.
Tagging, yes. So by default it uses default namespace because I didn't mention anything as namespace. But if you want to explicitly deploy into production namespace or Unity namespace, you do that so that it becomes a group and it becomes easier for you to delete. So you just delete the namespace, everything inside it is deleted. Right? So cleanup is easier.
In your diagram, you mentioned about accessing to public IP. So how do we access this AKS private IP?
You cannot.
Private AKS.
No, you cannot. You either have to be part of the same network. If you use Azure virtual network, it will be part of the same network and then you can ping the private IP, otherwise you cannot.
Can you make this AKS as private AKS?
Yeah, you can make private. So if let's say you have a web interface which is a public IP address and it reaches the AKS privately using the private IP address because you don't want external people to reach out AKS directly. You have a web site hosted which is part of the same network which allows the AKS to talk to, right? So there is an internal tunnel established, but for external people they cannot reach out AKS.
Privately,
Not privately, well, it's a virtual network. So it's like a network. You have network for the AKS, you have network for the website, but the website also have a public IP address for external people to reach out. You land into website and then website calls the AKS on behalf of.
so there is the LSD control in the network security group.
Yeah, you can define all of this. Yeah, you can actually.
that will happen at private.
Yeah, that will happen behind the scene, like your data access layer. You don't have the API publicly available for data access layer, right? So you always have it for application, and then application talks to the data access layer, right? So the same way. All right. So thank you so much.